Hello friends, welcome to Physics in 20 minutes. In this video we are going to talk about projectile, basic assumptions in the theory. We will derive the equation of trajectory and we will see what kind of trajectory it is. Prerequisite for this is video number 18, if you please go through that. So what is a projectile? A projectile is nothing but if you throw a body in air where you give some initial velocity to the body and body is free to move under gravity. The motion of such bodies is called as projectile motion. There are plenty of examples we see around. For example, if you kick a football or if you fire a bullet, a small object tossed in air like a piece of chalk is also a projectile. Some more projectile examples could be like a cricket ball. Whenever the ball leaves the bowler's hand, it becomes a projectile. Or whenever a batsman hits the ball becomes a projectile. So we deal with projectile in day-to-day life in various possible ways. The path followed by the projectile is called its trajectory. We have learned earlier that physics is all about model making. So in the projectile model, there are certain basic assumptions that we are going to look into right now. These assumptions are: number one, body is a particle. Now this is a very important assumption. Remember, a particle is a very small object. So suppose if you kick a football is a fairly large object than a particle. But here in this topic, we are going to assume that the football is a particle. Or similarly, any object which is tossed in air, no matter what its real shape is, we are going to take it as a point object or a particle. The second assumption is acceleration due to gravity is constant in magnitude. Now what does it mean? Acceleration due to gravity changes with height. So as you go higher up from the Earth's surface, the acceleration due to gravity generally decreases. We will assume that the height of projectile is not much, and you can safely assume that the gravity is constant. The third assumption is Earth is flat and gravity works vertically downward all the time. Now this is another important assumption. We know that Earth is not flat. Earth is a spherical in shape, but for all practical purpose, as far as our view goes, more or less the Earth looks flat. Remember, if the Earth is not flat, then the gravity will work radially inward towards the center of Earth, which is out of the scope of this topic as of now. We are looking at small scale projectile motion, and therefore we can safely assume that the Earth is flat and the gravity works vertically all the time. Another thing that we are going to ignore is air resistance. The air offers huge resistance to the moving bodies, and because of which their parameters change. But right now here we are going to assume that the Earth resistance and its effects are negligible. Once we do Newton's laws of motion, perhaps we will be in a position to discuss the effect of air resistance. So what are the important characteristics of projectile motion? Number one, the motion is always in one plane, or it is a two-dimensional motion. Anyways, if you throw an object in air, look at its motion carefully. You will find that the motion is in one plane. A plane can be described by two axes, x and y, or two dimensions, and therefore we say that the motion of a projectile is a two-dimensional motion. What determines the plane? So there are two prominent vectors which work in the formation of a projectile. Number one, the initial velocity vector, which is decided by the person who throws the projectile. And number two is the acceleration due to gravity vector, which always works downward. Now, the plane in which these two vectors lie is the plane of the motion of the projectile. And gravity itself cannot change the plane of the motion. Therefore, once the projectile is in space, its plane is fixed. The motion of the projectile can be split into two components. One is a constant horizontal motion, and second is a vertical motion under gravity. Remember, since we ignore air resistance, the horizontal motion is almost remains constant. So we can analyze x and y coordinates and analyze the two dimensions independently. Let's talk about the frame of reference that we need. For all the problems in physics, we need some frame of reference. Since the projectile is a two-dimensional motion, we can take two axes, x-axis and y-axis. We always call horizontal axis as x-axis, the vertical axis as y-axis. Any particle's initial position can be written as x0, y0, where 0 represents the positions at time t is equal to 0. The situation can be simplified if we switch the origin at the position of the particle, and therefore most of the projectile problems assumes the starting of the motion at the origin of the coordinate system. So in the beginning, both the coordinates x0, y0 are 0. Now you impart a velocity to the projectile. Initial velocity vector can be given as vector v0. Its magnitude can be written as v0. And the angle it makes with the x-axis, which is also called as projectile angle, is alpha 0. Also, once the particle is thrown, the v0 and alpha 0 becomes the constants of the motion. They are the parameters defined at the time of projection. Once the body is in air, it cannot go back in time and change these parameters. So v0 and alpha 0 are the constants of the motion. The initial velocity vector can have x component, which can be written as v0x, and v0x will be v0 cos alpha 0. You can see from the diagram that this is the adjacent component of the velocity vector. We can have a vertical component. The vertical component is v0y. You can see that this side is same as this side, okay, and this side is opposite to alpha 0, so it's a sine component, and therefore v0y is v0 sine alpha 0. We get a right angled triangle here. You can see that this is v0x, this side is v0y, and this side is v0. So you can use a Pythagoras theorem to relate them. v0 is equal to v0x square plus v0y square, everything under root. To find out angle alpha 0, we can take tan of alpha 0. The tan of alpha 0 is side opposite upon side adjacent. So v0y upon v0x is tan alpha 0. What is the vertical acceleration? The vertical acceleration is ay, which can be written equal to g. The horizontal acceleration is ax. There is no horizontal acceleration, ax is 0. As a projectile moves in space, it moves vertically as well as horizontally. Both the components of its motion happen independent to each other. So let's consider a projectile which is projected with an initial speed of v0 at an initial angle alpha 0 with respect to x-axis. Components of initial velocity are v0x and v0y along x and y axis respectively. As the particle moves in space, since there is no acceleration along x-axis, the x component of the velocity remains the same, that is equal to the initial x component v0x at all positions. While there is an acceleration due to gravity in the downward direction, the vertical component of velocity keeps changing. As the projectile goes up, the vertical component of velocity decreases first. The Vy at this position has a smaller magnitude than V0y. At the highest point, the particle stops moving in vertical direction and vertical component of velocity is momentarily 0. As the particle moves forward, the vertical component of velocity reverses its direction towards downward, and then it goes on increasing as the particle moves forward. The net velocity vector at any position is given as the vector sum of the horizontal and vertical velocity vectors at that position. Since the vertical velocity vector is changing, the net velocity vector keeps changing at all positions. the angle made by the velocity vector with the horizontal changes continuously along the path of the projectile. So let us summarize. The x component of velocity remains constant all throughout. The y component of velocity keeps changing. If the projectile is projected upward, then it goes on decreasing first. At the highest point, the y component becomes 0. At the highest point, the x component of the velocity is the final velocity. After that, the y component points in the downward direction. Since y component is changing continuously, the velocity vector changes continuously, and the angle made by the velocity vector with the horizontal also changes continuously throughout the path. So let's take each axis at a time. First, constant horizontal motion, that is motion along x-axis. We will write the kinematical equations for it very quickly. So the acceleration along x-axis, ax is 0, there is no acceleration. Velocity along x-axis, vx is v0x plus axt, but since ax is 0, velocity at any position x is v0x, which is nothing but v0 cos alpha 0. We have seen that v0 and alpha 0 are constant, and therefore the x component of velocity remains constant all throughout. What happens to position? This is our position equation. Now again ax is 0 and x0 is 0, so x becomes v0 xt. You can see that x position or position along x-axis changes linearly with time. Now from this I can find time at any instant. So time is equal to x upon v0x. What about the vertical component of motion along y-axis? So we can do it in a very similar way. Acceleration along y-axis is minus g. Velocity along y-axis will become v0y minus gt. Position along y-axis can be written as y is equal to y0 plus v0yt plus half ayt square. Now y0 is 0 and ay is minus g, so we can put the values, and this is our equation for position along y-axis. Now we are in a position to derive the equation of trajectory. A trajectory equation for any particle is nothing but the equation relating x coordinate with the y coordinate. So we have got two equations so far. One is equation of x coordinate relating to time. We can use this equation in the y equation to eliminate time altogether. So t is equal to x upon v0x. We can use this in place of t in y equation and solve and put those initial values and solve it further. You get this long equation. You can see that sine alpha 0 upon cos alpha 0 is tan alpha 0, and v0 will cancel. Here there is some square, so you can solve this and you get this equation. Y is equal to x tan alpha 0 minus g upon 2 v0 square cos square alpha 0 x square. This equation is an equation in x and y only. You can see that this relates x coordinates with y coordinates, and there is no time here. And this equation is called as equation of trajectory. So what is the nature of equation of trajectory? So if you look at this equation more carefully, you will see that since alpha 0 is a constant, tan alpha 0 is a constant, and here everything is apart from x square is constant. So g is a constant, 2 is a constant, v0 square is a constant, and alpha 0 is a constant, so cos square alpha 0 is a constant. So I can reduce this equation to this form, ax minus bx square, where a and b are two constants. What is the type of this equation? How would this equation look like when you plot it on a graph paper? So when you plot this equation on a graph paper, it will look like the equation of a geometrical shape which we call as a parabola, and therefore the trajectory is parabola. So if I have an x-axis and y-axis, if you project a particle in air, the path that it will follow, it will look somewhat like this, which is nothing but a parabola or a parabolic path. In this video we will stop at this moment. We will continue in the next video. Thank you.